On a high-resolution display, engineering a lightweight polymer component looks flawless. You map the structural integrity, highlight the green zones, and admire the theoretical perfection of your design. That confidence usually follows you into the lab, where preliminary prototypes hit their target density reductions and pass every basic stress test you throw at them. But theoretical models rarely survive the brutal transition to the factory floor.
OnlyTRAININGS. Learn what works in the industry.
The moment a supposedly optimized structure faces the harsh mechanical stresses of transportation or field usage, it begins to yield, warp, and fracture. Because stripping away material volume and dropping the overall mass of a part is incredibly easy. The actual engineering tightrope is maintaining reliable, high-performance structural integrity when you have far less material to rely on. The minute you aggressively cut density, you destroy the stiffness balance of the entire polymer matrix. Try to tweak the compound to get that rigidity back, and you instantly trigger severe brittleness, ruin your impact resistance, and lose all dimensional stability. Push that compromised material into an injection mold, and you will pull out components marred by deep surface sink marks and processing instabilities. Solving one of these problems in isolation almost always guarantees a new failure somewhere else on the line. You cannot navigate this using outdated academic theory, especially when designing for the immense physical demands of modern electric vehicles or advanced consumer hardware. Today's formulators are fighting a brutal daily war to balance unyielding impact requirements against tight production costs and manufacturing stability. The harder you push the boundaries of material reduction, the closer your component edges toward inevitable collapse. Surviving scale-up requires strategies built by the active industry professionals who have already fought through these exact factory floor failures. How do you lock in perfect dimensional stability during aggressive density reduction? What is the exact reinforcement balancing strategy needed to absorb a massive shock without shattering? The OnlyTRAININGS Engineering Lightweight Polymer Structures for High-Performance Applications Expert Quick Session is built to give you those exact answers. Inside, you will explore the smarter filler strategies, the mineral and microsphere configurations, and the precise molding parameters required to eliminate warpage and sink marks for good. Enroll today, access the complete training, and master the practical techniques required to drop the weight without sacrificing a single ounce of reliability.